Hi everybody. That's the second tutorial session of the series Circuit Theorems. This session we're going to explain source transformation, and the question is, when can we use source transformation? We can use source transformation when you have in a circuit mixed sources. I mean, you have voltage sources and current sources, and you will find it's hard to solve it with these sources, and sometimes it's easy to solve the circuit if you make transformation from voltage source to current source or from current source to voltage source. Okay. Question: how can we transform voltage source into current source? Simple. Always the voltage source is connected in series to a resistor. So to find the value of the current source, divide the voltage by the resistor. So you'll have IS is equal VS over R. And you connect the resistor in parallel to the current source that you got. So that's how you transform it. Well, you can do the opposite way. If you have a current source, you want to convert it to voltage source, so all what you're supposed to do, multiply the current by the resistance, you get the value of the voltage of the voltage source, Vs. And the resistance should be connected in series with the voltage source. So that's all. Let's take an example, simple example, how to solve electric circuit using this kind of transformation. In this circuit, you have two types of sources, current sources and voltage source. Sometimes it's fine to have both and you can solve the circuit easy. But here, we can see some kind of difficulty, especially when you see this kind of T section, or it looks like T, the 2 and 3, and then in the middle 8. You don't have all series or parallel. So you got to do some kind of transformation. I have now, I can do this one. I can transform it. The current source, the voltage source can be transformed to current source. How you do that? You divide the 12 by 3, so you'll have 4. 12 by 3 is equal 4 ampere. And the resistance should be in parallel, 3 ohm. Then you ask, the arrow directed upwards or downwards? You look at the polarity. The polarity of the voltage is positive, so it's upward. Okay, you have another one here. You are going to transform this current source in parallel with R ohm, so you can transform it to voltage source. How we do that? This is the voltage source. The magnitude of the voltage source is equal 4 times 3. That's equal to 12 voltage. And in series with 4 ohm. Now we ask the polarity of the voltage source in the top or on the bottom. Look at the arrow of the current. The arrow of the current upward, we can put positive in the top. Downward, the positive in the bottom. It's downward, so the positive in the bottom. So now we got the two transformations. So replace these two sources in the circuit. Okay. So that's the original circuit. That we have the 2 ohm. And you got the 8 ohm here. And this side we have the current source. 3 ohm. Upward 4 ampere. On the other side you got the voltage source. $12 voltage. Okay, the circuit is not simple yet. So what should we do? Well, 2 and 4, they are in series. So just you can add them and make it 6 ohm. That will make it simple. 6 ohm. All right. And if you transform the voltage source to current source, it will be much easier. So you have 12 divided by 6, you will have 2 ampere in parallel with 6 ohm. You will ask yourself, the arrow should be upward or downward? Look at the polarity. Downward, so downward. Now we're going to replace this one in the circuit. Let's sketch the circuit now. 4 ampere And on the other side, you have 1 down here, 2 ampere. And then you got 6 ohm here. You got 3 ohm here. And in the middle, 8 ohm. That's where you want to find the output voltage. The question was about this one. All right. This node are connected. It's only one node. And that's why, I'd like to sketch it in the front way. Because they are one node. There is nothing. So we can make it like that, It's one node. So if you have 4 ampere in and 2 ampere out, it means you subtract 4 minus 2 will be 2 ampere in. All right, that's another simplification. So it is this one. And now it's not 4, it's 2. Okay. 3 ohm and 6 ohm in parallel. Now you tell me, okay, 3, 8, 6 all in parallel. Why are you choosing 3 and 6 only? Because 8 ohm is the one that you want to find the output voltage. So what is the value of 3 and 6 in parallel? As you know, you multiply 3 times 6 and divide it by the sum. So it will be 3 times 6 divided by 9. By 3 is 1, by 3 is 3, by 3 is 2 ohm. 2 ohm. All right. So the circuit now is much easier. I will just remove the 6 and the 3 and put 2 ohm. So just, it changes to 2 ohm. 2 ohm. But we still have our 8 ohm. That is, our output. How can you find the voltage here? Find the current here. How you find the current here? Current divider. How you use current divider? Say, okay, the current in this branch, I, is equal the total current into the node, which is 2 ampere, times the opposite resistance. What does it mean, opposite resistance? It means if you want to find the current in this branch, don't use this resistance, use the other resistance, which is 2 ohm, divided by the sum of the two resistance, 2 plus 8. So it will be 4 over 10. It will be 0.4 ampere. When you have 0.4 ampere, that's the current in the 8 ohm. So what is the voltage? Very simple. Just multiply the current by the resistance. So the voltage will be the current 0.4 ampere times the resistance 8. So that would be the voltage. And the problem is done. Thank you, Fred.